Hello, welcome to Miss YY channel. Today we are going to continue on chapter 4.2 Stoichiometry. For the chapter 4.2 part B, we will cover on the definition of limiting reactant, theoretical and actual yield, and also percentage yield. And this subtopic we will perform calculations involving limiting reactants and percentage yield. So first, define limiting reactant. Limiting reactant is the reactant that are completely consumed at the end of the reaction, and its quantity limit the amount of the product form. So it means that at the end of the reaction, there will be no more limiting reactant left. And excess reactant is the opposite, which is the reactant that is left over, and it is not completely consumed in a reaction when all the limiting reactants is used up. Okay, so now let's look at the example. So I'm going to use a more simple methodology, okay, to show you what is limiting reactant. So for example, on a cooking recipe, okay, it says you need 3 eggs and 4 cups of flour to produce 1 cake. Okay, so this is what we say theory based on the cooking recipe. So if in the kitchen, okay, you have 6 eggs and 12 cups of flour, okay, so which is the limiting reactant? So now we can use a stoichiometry relation, okay, to find the limiting reactant. So based on the cooking recipe, okay, 3 eggs will need 4 cups of flour. So in the kitchen, I have 6 eggs. So if I have 6 eggs, how many cups of flour is needed? So we do the cross multiply. So 6 multiplied by 4 divided by 3. So the number of cups needed if I have 6 eggs will be 6 multiplied by 4 divided by 3. So I will need 8 cups of flour. So it means that if I have 6 eggs, I will need 8 cups of flour. So the number of the flour needed is 8, and I am given 12 cups of flour. So it means that I have 12 cups of flour, but I only need 8 cups. So it means that there will be excess of flour. So I can say, in conclusion, the number of cups of flour given is more than the number of cups of flour needed. So the flour is excess reactant and the X is the limiting reactant. So it means that at the end of the reactions, if I'm using 6 eggs, I will need 8 cups of flour. So there will be 4 cups of flour, which is leftover. So flour is excess reactant and X is limiting reactant. Okay, so by using the same cooking recipe, okay, 3 eggs will need to react with 4 cups of flour to produce 1 cake. So in your kitchen, you have 6 eggs and 12 cups of flour. So how many cake can be produced? So when we are calculating the product form, okay, the number of the products depends on the limiting reactant. So when we do the stoichiometry relation, okay, we have to compare products with the limiting reactant, which is X. So based on the stoichiometry, 3 eggs will produce 1 cake. So when I have 6 eggs, how many cake can I produce? So we do the cross multiply. So 6 multiplied by 1 divided by 3. So I will get 2 cakes. So remember, the product is depends on the limiting reactant. Okay, so why we cannot use the excess reactant, okay, to compare with the products, okay? So let's say if here I use the flour, okay, the stoichiometry relation is 4 cups of flour will produce 1 cake. So in the questions, okay, in my kitchen, I have 12 cups of flour. So when I have 12 cups of flour, how many cake can I produce? So in the stoichiometry relation, 12 multiplied by 1 divided by 4. So when I have 12 cups of flour, I can produce 3 cakes. Okay, however, okay, if you use SES reactant, okay, to compare with the amount of product form, okay, this is wrong. Okay, because if we have 12 cups of flour, we can produce 3 cake. Okay, however, to produce 3 cake, okay, we need 9 eggs and 12 cups of flour. Okay, and in the kitchen we only have 6 eggs. Okay, so you won't be able to produce 3 cakes because in the kitchen we only have 6 eggs. So means that there's no enough eggs, okay, to produce 3 cakes. So remember, when we are calculating the amount of product form, okay, you have to compare with the limiting reactants. Okay, so now after the methodology, okay, we are going to look at the steps, okay, in calculating limiting reactant. So first, we must write a balanced chemical equation. Okay, so sometimes the balanced equations is given in the questions. And then step 2, okay, we have to calculate the number of mole for each of the reactants. And then step 3, okay, so you can write the stoichiometry equation. And based on the stoichiometry equation, the step 4, we are going to compare the number of mole given with the number of mole needed. And based on the step 4, then we can find the limiting reactant. So if the number of mole needed is less than the number of mole given, so it means that if we need more than given, so that reactant will be the limiting reactant. And then we can make a conclusion. Okay, so take notes, okay? So we always use the number of mole limiting reactant to calculate the any other amount of substance, okay, including the products. Okay, so now let's try an example questions. Urea is prepared from reacting ammonia with carbon dioxide. So the reactant is ammonia and carbon dioxide, and I'll produce urea and H2O. So in one process, okay, 637.2 gram of ammonia are allowed to react with 1142 gram of carbon dioxide. So we want to, okay, question A, we want to find which of the two reactants is limiting reactant. And question B, we're going to calculate the mass of the product, which is urea. And then the C is how much excess reactants is left. Okay, so the question gives you the mass, so we have to find the number of mole of the both reactant. So the number of mole of ammonia is 637.2 divided by the molar mass. So the number of mole ammonia given is 37.48 mole. And the number of mole carbon dioxide gas will be 1142 divided by the molar mass, which is 12 plus 32. So there are 33.59 mole of carbon dioxide. So these are the mole given. So based on the balanced stoichiometry, based on the, so we can write the stoichiometry equation is 2 mole of ammonia will need to react with 1 mole of carbon dioxide. So if I have 37.48 mole of ammonia, how much carbon dioxide will be needed? So the number of mole carbon dioxide can be found by using the cross multiply method, which is 37.48 multiplied by 1 divided by 2. So I will get the number of mole of carbon dioxide needed is 18.74 mole. So it means that if I have 37.48 mole of ammonia, I need 18.74 0.74 mole of carbon dioxide. So this is what I need. And compare with the number of mole of carbon dioxide given, I'm given 33.59. Okay, I have 33.59 and I only need 18.74. So we can write on the conclusion, which is the number of mole of carbon dioxide given is more than needed. So carbon dioxide is excess reactant. So my ammonia will be the limiting reactant. So question B, calculate the mass of the urea. So as I mentioned just now, the amount of product depends on the limiting reactant. So our stoichiometry relation, we have to use the ammonia to compare with urea. So 2 mole of ammonia will produce 1 mole of urea. So if I'm having 37.48 mole of ammonia, how much urea can I produce? So 37.48 multiplied by 1 divided by 2, the number of ammonia produced is 18.74 mole. So 37.48 mole ammonia will produce 18.74 mole of urea. So to find the mass, I will use the number of mole multiplied by the molar mass. So the mass of the urea produced is 1124.4 gram. For part C, we are going to see how much excess reactant, which is carbon dioxide. So how much carbon dioxide is left at the end of the reaction? So the number of mole given is 33.59 mole, and then we only need 18.74 mole of carbon dioxide. So to find the excess mole, we can use the number of mole given minus the number of mole needed. So I have 14.85 mole left. Okay, so to find the mass of excess reactant, I can use the number of mole multiplied by the molar mass, which the mass of excess reactant will be equal to 65.34 gram. Okay, so next percentage yield. Percentage yield can be defined as a ratio of the actual yield to the theoretical yield multiplied by 100%. So actual yield is a mass or the amount we obtain from the experiment, and the theoretical yield is a calculation based on the stoichiometry. So actual yield, okay, if normally it's a bit difficult to get 100% of percentage yield, okay, because it might have some error happen during the experiment. Now, okay, let's look at the calculation. Okay, so for question D, if 1050 gram of urea is obtained at the end of the experiment, calculate the percentage yield. So we have calculated just now. Okay, from the part B, the mass of urea is 1124.4 gram. So means that if based on the stoichiometry relation, okay, I can get 1124.4 gram. So means that if the experiment is all going well, okay, there's no error, okay, I'm supposed to get this amount of product, okay, 1124.4 gram amount of urea. But then at the end of the experiment, I only get 1050 gram. So the 1050 gram here is my actual yield. So to calculate the percentage yield, I put the value into my formula. So actual yield is 150 over my theoretical yield, 1124.4 gram multiplied by 100%. So my percentage yield is 93.38%. So it means that the higher the percentage yield means it is better because we are getting more products from. So I hope based on the stoichiometry relation, you'll be able to detect the limiting reactants, calculate the mass of the product, and also percentage yield. So if you like my video, please like, share, and subscribe. Thank you.